Hey everyone, hope you're doing well. My name is Rahul Paul and welcome to my channel Learn with RP Sir Mtech JU. In this particular video, today we are going to discuss a question on partial fraction integration. In the last video, we have discussed about what are the theories related to partial fractions and what are the different forms of partial fractions which are usually used in integration problems. So we are going to discuss an example from that today, and we will try to explain how the partial fraction is actually helping us in order to solve this particular problem. Okay, so let's get started with this particular example. So it's integration dx over x plus 1 times of x plus 2. So this is the particular question that is given to us. So now, how do we solve this one? So first of all, what we need to do is we need to write it in terms of the partial fraction. So if you just relate to the forms of the partial fraction which I have given, so this is the one which is given, and you can see that the denominator has two linear factors which are not equal to each other. So this is a case of distinct linear factors, and in distinct linear factors what we do, we will represent it as a over x plus 1 plus b over x plus 2. Okay, this is how we are representing. So from here what we can do is I can again write 1 over x plus 1 times of x plus 2, and here we can combine the two. We can write the denominator x plus 1 times of x plus 2, and we can write over here is a times of x plus 2 plus b times of x plus 1. It is very simple addition of fraction, that's it. So now you can see that the denominators are same, which means we can eliminate the denominators and we can simply write 1 equal to a times of x plus 2 plus b times of x plus 1. So this is the particular equation which we need to solve now. So this is the partial fraction form which we need to solve. Now let us take different values of a. So first of all, let us say that we want to eliminate the a portion and we want to find the b portion. So for that we need to make this particular bracket as 0. So we can take x equal to negative 2. So if we take x equal to negative 2, in that case I can write 1 equals to, now see, 1 is not going to change because there is no variable over here, so there is no putting of negative 2 on this particular part. However, in this particular part it will be negative 2 positive 2, which means this will be 0, which means a is gone. So I'm just writing b times of negative 2 plus 1. Okay, a will be eliminated because this bracket will give 0. Can you understand this? If you put x equals to negative 2 over here, so it will be negative 2 positive 2, so this will be 0, and a times 0 will be 0, so this particular part is gone. It is not going to participate in this. So from here what we can write, we can say 1 is equal to b times of negative 2 plus 1. What is that? It's negative 1, which means that b is equal to 1 divided by negative 1, and that is nothing but negative 1. So the value of b is coming as negative 1. Okay, the value of b is coming as negative 1. Now we have to find the value of a. So what we can do is we can again take the value of x as such a value where this bracket becomes 0, and hence b times 0 will become 0. So if I take x to be equal to negative 1, so what happens? Now see, this 1 again will not change because there is no variable here. Okay, there is no variable. Whatever value of x you put in, this will never ever hamper this. Okay, because there is no variable here. On the contrary, here it will be a times of negative 1 plus 2, and this part is gone. Why? Because it will be negative 1 plus 1, which means this bracket is 0. B times 0 is 0. So we will be just left with a times of negative 1 plus 2, which means that it will be 1 equals to a times of 1, which means that a will be equals to 1. So this is the value of a. So we have got the values of the constants a and b. Now we are going to proceed with the partial differentiation forms. Sorry, partial fraction form. So the integration of dx over x plus 1 times of x plus 2 can be written as integration of a. What is a? 1 over x plus 1 dx plus integration of b. What is b? Negative 1 over x plus 2 dx. Now since they are constants, they will be staying outside. So it will be simply integration of dx by x plus 1. 1 is outside. So it will be logarithm of x plus 1 plus, here negative 1 will stay outside and it will be logarithm of x plus 2, and plus c because it's an integration, an indefinite integration, and there we have to add plus c. Now logarithm of x plus 1 minus, now why minus? Because plus 1 times negative 1 times plus is minus, logarithm of x plus 2 plus c. Now there is a logarithm rule which says that log m minus log n is equals to log m by n. So here it will be written as logarithm of x plus 1 over x plus 2 plus c, and that is the final answer. Okay, that is the final answer. So let us again do a little bit of recap with what we have done. First of all, this was our question. So what we did, we have broken it in terms of the partial fraction form, because this is from the linear factor which are not same, distinct linear factor. So this is the formation of distinct linear factor in terms of partial fraction. Then we have done the addition of fractions. We eliminated the denominator. We came up with this particular expression. Now we took x is minus 2 so that we could eliminate the a portion and get the value of b, and then we took x equals minus 1 so that we could eliminate the b portion and get the value of a. And then what we did next, we then put the values of a and b. So a was this one and b was this one, and now integration of dx by x plus 1 is logarithm of x plus 1 and dx by x plus 2 is logarithm of x plus 2, which we have put, and we have finally simplified and got this particular answer. So with this we finish this particular question, and this is all for this particular video. On the next video we are going to do another kind of question on partial fraction, which is based on another form of partial fraction, so that we can understand how to execute that problem. Okay, I hope you have liked this video. If you have liked it, please don't forget to subscribe it, and please follow us for more coming videos in future. Until then, take care. Have a